Hi guys, I hope all of you are doing good. So today we are going to look at a new topic called sets. Okay, this is slightly easier topic compared to others in mathematics. So let's explore sets and understand that what is sets and what are the basic concepts around sets so that we can get started with this. Okay, so what is a set basically? A set is nothing but it's a collection of items or objects. You can name it as is, right? So for example, right, the simple example, colors of a rainbow. Colors of a rainbow, right? We know that it's nothing but Vibgyor, right? We know that it has 7 colors and we call it Vibgyor. So this is a set, right? Similarly, days of a week. Days of a week, right? It's again a set. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Similarly, you'll have your months in a year. So these kind of things are all called as a set, right? Okay. So now related to these sets, right, we have certain terminologies which you need to understand before you get into this one and start applying them in real world problems. Okay. So let's look at those. What are the terms which we use in sets? Okay, the first and foremost term is known as, for example, let's take an example and then we'll do it. Suppose there is a set A, which is a collection of numbers like this, 1, 2, 3, 4, 5. And there is a set B, which is having, say, 3, 4, 5, 6, 7. Right? It becomes very easy to understand when we are discussing those terms, when we take an example and I'll be able to explain you much better. The first term is known as element. Okay? This is known as element of a set. Element of a set. For example, in this particular case, if you look at it, what are the elements of set A? It's 1, 2, 3, 4 and 5. Those are the values which are part of set A. Similarly, you have 3, 4, 5, 6, 7 are part of set B. That is when we denote it like this. See, 1 is an element of set A. Make sense? So similarly, 2 is an element of set B. Similarly, 3, if you look at it, 3, 4, 5. 3, 4, 5 are elements of set A and B. That is how we signify it. Okay, we show it. Now the next one. The next one is a not condition of the same one. This is known as not an element of. Not an element of. Not an element of a set. So these are symbols which you need to remember, because most of the time in sets what happens is that they are going to use symbols. They are not going to write this English. A lot of English around it in mathematics. Okay. So for example, in this particular case, look at it. Is 6 an element of A? No. 6 is not an element of A. Similarly, 1 is not an element of B. Make sense? Right? Okay. So let's go to the third one. Suppose I take another set. I don't have any elements in that. What is it known as? It will be known as an empty set. There are multiple ways to empty set. This is an empty set or a null set. These are the terms which are, or void. There are multiple terms which they can use it. So remember these terms. Okay, null set, void set, or a trivial set, they call it some. So basically what they're trying to say is that there are no elements in that particular set when I take all 3 of them together like this. Okay, so next one is denoted by this one. It is denoted like this. What is this, you know? This is known as subset of. subset of a set. Okay, what is a subset of a set? For example, in this particular case, like, look at it. Now I can write C I have already denoted as empty set. So what I'm going to do is that I'm going to put D is equal to the values of D in that set is 1, 2, 3. So look at it. Can I write D is a subset of A? Why do I say that D is a subset of A? Look at the elements. Look at the elements what it has. It has 1, 2, 3. And A has 1, 2, 3, 4, 5. So I can call it this set, this one as D here, and D is part of A. That is what it signifies. Okay? Now, moving forward. So I hope it's very clear. These are very simple things which you have to remember, because these will be used, all these symbols are going to be used in your problems. Okay? So now the next one, cardinal number. You're going to use this term or hear it a lot in sets. Cardinal number is nothing but it's the number of elements in a set. Okay, and it is represented as a small n followed by the set name. What is the small n? It represents the number of elements in the set. So the number of elements in set A is 5. Similarly, number of elements in set B is equal to 5 again. So remember, this is a number. This is a quantity of elements in a particular set. Okay, so this is an important thing. Based on this one, we are going to have some formulas in sets, which I am going to show you further. So remember this one, cardinal number. Okay, so next we have something called equal sets. Equal sets. This is one more term. What do you mean by equal? Equal, there is one term called equal and there is one term called equivalent. Equivalent sets. There is a difference between these two. Okay, let me take an example. So suppose there is a set called A, B, C, and there is another set called similar A, B, C. Right? These two are equal. These two sets are equal because the elements within them are same. Look at it. That's why they are called equal sets. They are known as equal sets. But now, if I take an example over here like this, the same similar example, but I'll change a little bit. I'm going to put it as A, B, C, and Y set as D, E, F. Okay? Can you call them equal sets? No, because their elements are not same. Can you call them equivalent sets? Yes. Why, you know? Equivalent sets is nothing but n of x is equal to n of y. What is n of x? N of x is 3. There are 3 elements over here and there are 3 elements in this one. So these are known as equivalent sets. Okay? So basics, very basic stuff. Okay? Let's move on. Remember all these terms. It's very simple. This topic is very simple. If you remember these terms properly and do things in an order, right, you'll be able to solve all the problems. Okay, now let me take an example. X is equal to, again, the same thing, ABC, and Y is equal to DEF. Right? These are known as disjoint sets. Disjoint sets, X and Y, because they don't have anything in common. If you look at the elements of both these sets, right, there is nothing in common, so they will never overlap with each other. That is what we are trying to say. For example, if you look at this one, the set A has these elements 1, 2, 3, 4, 5, and set B has 3, 4, 5, 6, 7. Can we call them disjoint sets? No. Why? There is an overlap of elements over here. Look at it. they overlap with each other. Okay, that's the difference between a joint set and a disjoint set. Disjoint set is simple, they don't overlap. Okay, that is another one. So next, very important things, very important symbols, two symbols you're going to remember, because this chapter will basically ask you questions related to those symbols. You have something called a U, big U. It is known as union. Union of sets. Union of sets, remember U. And if it is a reverse U, the inverted U, it is known as intersection of sets. I'll explain with an example, don't worry. Okay. Now, if I want to calculate the union between A and B, I write it like this. A union B is equal to. Now what happens is that you count all the numbers and put, if there are common items, right, you put them only once. So A union B, the union of these two sets will give you this value. 1, 2, 3, 4, 5, 6. I'll write the end, all the elements of set A, and then I'll write only the ones which are left out in set B, because we have already taken care of 3, 4, 5 in set A. Make sense? So this is known as union. Union means all together, putting them together. Okay? This is also known as OR. OR gate. We call it as a OR gate, which we use in computers, right? A lot. And this is known as AND gate. AND. A and B. Here union means, it is, why we are saying it is OR, because it is either present in this one or it is present in this one. So I'm going to take everything together. Similarly, so now if I go to intersection, what is the intersection of A union B? You are going to only pick up the elements which are common in these two. They are present here and they are present here. That's why it is AND. Remember these two terms. Okay. So your common items are 3, 4, 5. That's it. Understood? Very basic stuff, very conceptual stuff which you need to understand to be able to understand sets nicely. Okay. Next up, let's understand what are infinite sets and finite sets. Okay, so these are two more terms which can be asked in your school exams and all. So infinite sets are nothing but sets which keep on going. You cannot basically write it in a form of a set. Okay, for example, whole numbers, right? They start with 0 and they go on till infinity, right? They go on. So this is an example of infinite set. Similarly, natural numbers, right? Similarly, your rational numbers, right? Similarly, your positive integers. Similarly, your negative integers. So these are all infinite sets. Similarly, your irrational numbers. These are all your infinite sets. Okay, and finite sets, I gave you an example earlier in the video, right? Your colors in a rainbow. Colors in a rainbow is a finite set. Then you have days in a week, months in a year, right? For example, what else we can have? Number of games played in a particular school. It can be infinite, but you can define it at least. I don't think so a school will allow you to play all games what are present in the universe, right? That is one thing. So that is the difference between infinite set and finite set. Now let's move forward understanding what is a superset, right? We have looked at a subset, right? We have looked at a subset. Subset is this one. What is a superset? Superset is nothing but given by a symbol like this. This we call it as the universe. Remember always. This symbol, whenever you see, right, it is a universe or a universal set. I'll give you an example to make you understand very easy between these two. So this is a subset. this is a subset, and this is a universe or a universal set. For example, if I write it like this, the universe, if you look at it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose there are 10 elements in the universe, right? So now if I want to write any sets, right, which are part of the universe, I can put it like this: 1, 2, 3, 4, 5, 6, right? B is equal to 3, 4, 5, 7, 9, and there can be a C. C is equal to, say, again 1, 10, say 7, 8. So if you look at it, right, these three sets are part of that universe. Basically, these are the subsets of A. I can write it as A is as a subset of your universe, right? Similarly, B is a subset of the universe. So I should write this symbol properly. So this is like this, right? They denote it like this. Let me take another stab at it. So they denote it as like this, okay? Universe, remember. But can I write this one? This is a superset and these are the subsets. So there is a difference between a superset and a subset. Make sense? So next up, there are two terminologies which we are going to use in sets most of the time, right? In problems, they are going to use these forms. One is known as the roster form and another is known as a set builder notation. Now, what is the difference between these two? This one is mostly used for finite sets. Okay, this will be used for mostly finite sets and this will be used for infinite sets. Infinite sets. The reason why I am saying finite and infinite is that I'll explain it. Okay. You can use both of them for both the cases, but most of the time for infinite sets, they are going to define it this way because it's very difficult for me to put a lot of items in a set and show it to you, right? They will basically define it as a sentence over here. I'm going to show it to you how they're going to do it. For example, roster form. Roster form, right? I know that rainbow colors. Rainbow colors. The set will be equal to what? With your, I can always put it in a roster form like this because I know that the number of elements in the set is limited with your, another one in between, okay, with your 7 elements. Similarly, your days of a week. Days of a week is equal to, I know that it is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. I know very well, or like this. The same thing if I want to put it in a set builder form here, this one, right? How do I write it? You write R, set R, rainbow is equal to X, pipe symbol, X is to X. Then you need to write it as colors of rainbow. I told you, you can write it as a sentence over here. Okay, so this is how it signifies. This one again, how I want to write days of a week. Days of a week, I can write it. There is another, they put a is to symbol. So X is these values. These are the values which they are denoting. So I can put it as days of the week. Right? This is how it is. So if they give you this one and ask you to put it in the roster form, you are going to put it this way. If they give you this one and ask you to put it in a set builder notation, you are going to write it this way. Okay, now why do we use set builder notation? I'm going to go into more details around that one. Look at it. Let me explain. Because you can use the set builder and roster form for both of them, but it's very difficult certain times to write it in roster form. Okay, so now let's see. Now suppose they gave you a set like this. A is equal to X is to X. Okay, X is an element of natural number. They are defining that x is an element of a natural number and the value of x is less than equal to 20. Okay? Now look at it. Did you understand this bit? What they are trying to say is that this is in the set builder form. They are saying that build this set and show me. Set builder notation. This is in the set builder notation. Now they will ask you to, can you please give me the set in the roster form? That is what they are asking you to do, roster form. Okay, so now what will be a set in the roster form? Look at the condition what they have given. They are saying that x is an element of natural number, means it will start from 1. You cannot have a 0 there. And all the numbers less than equal to 20. So for your numbers 1, 2, 3, 4, it will go till 20. This is what your roster form set is. Makes sense? Yes? So this is what I was trying to help you understand. Okay? So anything, right? Anything which you want to do, they can give you a set builder notation like this and they'll ask you to basically write it in the roster form. Let's take another example. Okay? If they have given you something like this. Say A is equal to x is to x. X is an element of z. Z is nothing but integer. You need to know all these details, otherwise you will not be able to make sense of it. Z is an integer, okay? And they say that x is greater than minus 10 and less than 5. They are asking you to give me the possible values of this particular set with this particular condition. So now look at it. X is an element of z. Z means you have both positive and negative integers. And they are saying that x lies between these two numbers. Now it is simple. What are you going to do? If you have to write it in the roster form, how are you going to write it? Are you going to include 10 over here? No. They are saying that x is greater than 10. So the first value what are you going to use is minus 9. X greater than 10 is what? Minus 9. Minus 8, minus 7, it will keep on going like this. You will have a 0 in between till you hit positive, and then 1, 2, 3, 4. That's it. Because here again they are saying that x is less than 5. Make sense? Understood? This is what is a set builder notation and this is a roster form. Okay, this is very important. This is the first topic where you're going to get problems related to this one. So you need to understand this. This is the condition and these are the values which they are asking you to put it like this. Okay. Now next let's look at another terminology called complement of a set. Okay. Let me take an example to make you understand what do you mean by complement of a set. Here if you look at it, you have a universe which have the elements 1, 2, 3, 4, 5, 6 in it. A universe, right? And A has the elements 3, 4, 5. We always know that A will be a subset of universe. It will always be the case. Whenever you have a universe and there are other sets given to you, right? It should be a subset of it or it can be a null set. For example, if I write B is equal to like this, right? This is also an element of universe. Any null set is part of universe. Remember this one. There are no elements here and there can be a case that there are no elements, one more element over here without anything in the universe. That is also part. So I can easily write that A is a subset of universe and B is also a subset of the universe. Look at it. Okay. So now let's look at what do you mean by complement of a set. Complement. For example, they ask us to find complement of A. Complement of A. Complement of A is denoted like this with a slash on top of it. Okay, not a slash, what do you say? The single apostrophe. Okay, like this is denoted by like this. Now, what do you mean by complement of A? Look at A. What are the elements are there in A, but they are not present from the universe? So complement of A. So like if I write the set, right, it is nothing but if you compare it with the universe, right, it is 1, 2 and 6 because they are not part of set A. Got it? Similarly, complement of B will be what? Complement of B will be universe set completely. Look at it. 1, 2, 3, 4, 5 and 6. All of them. Because B is a null set over there. Understood? This is what is complement, because I just wanted to touch upon this one because this is going to be used in problems going forward when we are going to do more problems. So this is how you see it. And there is nothing called complement of universe because you are not comparing it with anything else. Here A is being compared with the universe, that's why you could find the complement. Here B is being compared with the universe, that's why you could find the complement. Remember this stuff. Quickly, one more thing which I missed to cover is that now let's look at, you have, now what do you get when you do this one? Look at it. I am doing a union of A which has 3, 4, 5 with the A complement. What are you getting? When you do this one, what do you get? You get 1, 2, 3, 4, 5, 6. Look at it. That is what union means. What? Elements in this one plus elements in this one. So what is this? If you look at it, it is nothing but it's the universe. Make sense? Right? So now next one. If you want to do a intersection of A intersection A complement, do you see any common elements over here in these two? These are disjoint sets. Look at it. You don't have anything. So this is nothing but it will be a null set or a void set or a trivial set. That is how they call it. Okay. Remember this one always. And one more thing is that the cardinal number of set A plus the cardinal number of complement of set A will always be equal to the universal set. Look at it. This is also coming true. What is the cardinal number of A? It is 3, right? It is 3. Plus, what is the cardinal number of complement? A complement? It is 3 again. And what is the cardinal number of this particular universe set? It is 6. Look at it. It's correct. So these three concepts are. So you don't have to remember all these things. They might ask you questions. If you understand the concepts well, you should be able to prove all of them. You should be able to find out them on the fly. Okay.